Hello everyone. In this video, we will learn briefly what is stereochemistry is, and our focus will be understanding three-dimensional structures of pharmaceutical drug. So basically we have understood molecules are three-dimensional in the nature and how substituents they do orient or make the arrangement around the stereo center that sometimes affects their physical, chemical and even biological properties. So before we proceed, I'll clarify certain points which are important for a beginner to understand what does mean by a chirality center, mirror images and so on. So chiral or asymmetric carbon is the one which is a tetrahedral carbon atom bearing four different substituents. Generally it is believed by student that only carbon could be chiral in the nature, but this is not the case. There are other elements are also there. When they become linked to different substituent, they will be called as stereo centers or chirality centers. Whereas a mirror image is the one which is nothing but the reflected duplication of an object. In our case it will be molecule, being a chemistry or pharmaceutical chemistry that appears almost identical. So whatever it becomes reflected from the mirror and which is duplication, we could say, that will be called as the mirror image. Here example of asymmetric carbon is there. You could see it has got linked to four different substituents like hydrogen, bromine, methyl and ethyl. Here you could see a quaternary nitrogen is there, which is again become linked to four different alkyl groups starting from methyl, ethyl, isopropyl and propyl. So this is how these are chiral in the nature, or these are called as a chirality center, or alternatively these are called as stereo centers, and for sake of understanding I have circled them. So briefly, isomers are the molecules or compounds having same molecular formula but their structural arrangement will be distinct or different, and those which exhibit this phenomena will be called as isomerism. Not necessarily isomers will possess all the property which will be similar. Depending upon what type of isomer it is there, either their property may vary. So briefly we will try to classify isomers into different. So main classification is there between isomers is constitutional and stereoisomers. Name itself is explanatory, constituent is different. Here bond connectivity between the atoms is different. This is the most important difference between constitutional isomers and the stereoisomers. You could see here oxygen has become linked to hydrogen and carbon, whereas here oxygen has become linked to 2 carbon. So molecular formula for these two compounds is same but the functional group is different. In one case it is alcohol and in another case it is ether. So this is how constitutionally they are different. Our focus will be stereoisomers. So stereoisomers are the one which has got same connectivity. So connectivity between the atom will always same, it won't differ, but they do differ in the three-dimensional arrangement around certain elements. So these are again further classified into configurational and conformational. So basically conformational isomers are the one which are formed due to rotation of a substituents around carbon-carbon single bond. So there is no restriction in the rotation of the substituent around carbon-carbon single bond. So these are the one which do differ in the arrangement of the substituent around the carbon-carbon single bond, and this is due to rotation of substituent around carbon. You can easily make out how two hydrogens and methyl group, and on another carbon one methyl and two hydrogen are there, but when you rotate substituent around this carbon-carbon single bond, position of methyl has become changed and these two are called as the rotamer of one another. So these are alternatively called as rotamer because they are formed due to rotation of substituent around carbon-carbon single bond. Whereas configurational isomers, they are of two kinds again, geometrical and optical. Optical name itself is explanatory, they are related to mirror images of one another. Now you will realize why I have explained mirror image in the beginning itself. So optical isomers, there are again two kinds, enantiomers and diastereomers. When isomers they are configurational in the nature. They do differ in the arrangement of a substituent. Configuration means arrangement of a substituent in the 3 dimensions. Their arrangement is such that they are mirror images of one another. So these are two which are enantiomer of one another, and if you try to put mirror in between these two, you could see that they are mirror images of one another, but that mirror image is non-superposable. If you try to superimpose these two on one another, you will realize that their mirror image is non-superposable. Whereas diastereomers are the one that they are not mirror images of one another, and that's why they are not enantiomer. So these are the one which are having same molecular formula, but they are arranged, their substituent are arranged in a such a manner that they are not mirror image of one another. So this is the basic difference between enantiomers and diastereomers. Whereas geometrical isomers are the one which are formed in alkene due to restricted rotation of substituent around the carbon-carbon double bond. Due to carbon-carbon double bond, these substituents are not able to rotate around this, and depending upon whether similar groups are arranged on same side of a double bond or on different side of a double bond, they are termed as cis and trans isomers respectively. The basic difference between geometrical and conformational, here there is a restriction in the rotation, whereas in case of conformational there is no restriction of a rotation of the substituent around carbon-carbon single bond. And geometrical isomers, that is cis and trans, they do possess the different physico-chemical properties. So enantiomers, briefly again I will explain you what is meant by mirror image and superimposable mirror image. So if you take example of our hands, left hand and right hand, they are mirror image of one another, but they are not superposable. When you try to put one hand over another, you could see that their mirror image is not superposable. But when you take example of a flask, of course it will be mirror image of one another and it is superposable. When you try to superimpose one over another, you will get this picture, and somehow we could see that this is a superposable image. So isomers having non-superimposable mirror image of one another will be enantiomers. For example, this is a hypothetical molecule having carbon at the center, and it has got linked 4 different substituents like A, B, C, D, and you could see its isomer or enantiomer, which is mirror image, but it is non-superposable. So these two are pair of enantiomers. So enantiomers, they do have identical physical properties like boiling point, melting point, density, solubility, refractive index, but only difference in between enantiomer is the way, the manner they rotate direction of plane polarized light. This is one more example of enantiomer where you could see that a model of compound which is there in front of you. I have marked carbon which is a chiral in the nature by a steric, and 4 different substituents are there, and you could see that these two are a mirror image of one another, but it is not superposable, so it is an example of enantiomeric pair. When it comes to diastereomers, we already learned these are not mirror images of one another. So here molecule is there around stereo center. If the arrangement of substituent is such that they are not mirror image of one another, that particular pair of isomer will be called as diastereomer. And these diastereomers, they do exhibit different physical properties like melting point, boiling point, solubility, density and refractive index, depending upon whether the nature of compound is solid, liquid and something like that.